Hello, everyone, and welcome to today's webinar, Spooky Experiments, Building Your Own Security Research Lab. My name is Melissa Russell, and I'll be the host for today's webinar. And before we get started, I did want to go over a couple of items. We are recording the session, and in the next day or so, everyone on here will get a link to the recording as well as a copy of the slides. If you do have any questions, please feel free to go ahead and enter them into the Q&A panel, and Paul will take some time at the end to address any of your questions. And at this time, I'd like to go ahead and introduce our speaker. Paul Azadorian is our Principal Security Evangelist here at Eclipsium. And Paul, the show is yours.
Thank you so much, Melissa. Welcome, everyone. I would also like to introduce the latest addition to my team. This is Bones. Bones will be helping me out during this presentation. He's an older intern, I guess you could say, but he'll be helping me out. It's a great worker. All right, just introduction to get things started, what we'll cover today. So we're going to learn how to set up a lab for hardware security testing and or reverse engineering. This presentation will largely be focused on the hardware end of things. We could do a follow-up one perhaps on software, but I'm not covering the software end, such as Ghidra and firmware analysis tools like Binwalk and things like that will not be in here. But this will kind of set you up that if you are going to do some hardware reverse engineering, obviously one of the goals is to get a console on the system and or be able to analyze the firmware on the system. That firmware analysis is not covered here, but all the hardware stuff you need to get there is. And also tips on what specific hardware will most likely work best for you. I had a lot of help from our internal research team here at Eclipsium and my good friend Larry Pesce. Should both get shout outs as they were very helpful in selecting all of this stuff. There's been a couple of projects that I've been working on that I'll talk about that facilitated the need for me to kind of build out my hardware lab, if you will. And so this is very much based on those experiences as well. Also, I mean, this is a shopping list. So if you're in the audience and you've been doing hardware hacking of any kind for a long time, or you work in the space and you do hardware reverse engineering as part of your job, I hope there's at least one or two things you're like, oh, I should go buy one of those things, but there might not be. So you can listen and hopefully be entertained and correct me as I go, maybe, perhaps. But this is more for if you're building a lab and just kind of getting into this as well. I failed to put a link to the Hardware Hacker's Handbook, but if you search for the Hardware Hacker's Handbook, that is a great book as a resource to get you started as well, and one that I looked at their equipment recommendations for as well. So always remember, when you're doing this kind of stuff, we're working with electricity. Remember safety first. Safety first. Okay, one of the projects that led me to this fine journey of needing a hardware hacking lab. In fact, I've got one of the devices right here. Gonna unplug it. And this was prompted by one of my coworkers, Chris. And I said, Chris, I've been reading these articles about these Android TV devices. I'm holding up an X88 Pro 10 right here. And he said, I said, these are coming pre-installed with malware. And he said, well, it'd be kind of cool to buy some of these devices because they're not expensive. They range in the $25 to $35 range. And so it'd be fun to get on and pull the firmware off and do some analysis. And so that was all it took for me to embark on this project where I analyzed. Now, I largely recreated others' research in this area. I don't think I did anything, necessarily new or groundbreaking, but it was a great exercise to go through and follow along at home, as this is how when you acquire the gear, how you do the reverse engineering and hardware stuff to get to the firmware. And that post that I linked to in this slide actually includes some tutorials on some of the software tactics that I used as well. So that's what kind of sparked this whole thing. And you may see other references to the work that I did for this post as it, I wish I had some of the other devices laying around, as it chronicles kind of my journey in purchasing cheap Android TV devices and discovering that they do in fact have come pre-installed with malware. That one that I held up actually has a stage 0 payload on there that tries to call out to a domain that has been taken down. So it's all chronicled in that post with links to lots of resources to other people's work in Android TV devices. So if you're interested in that, that's a good place to start. Okay. Also, I keep seeing this image. I don't know where this image came from initially, but it's like some marketing promotional image, and people that do hardware stuff like to poke fun at it, but this is scary. But also a reminder that safety is important. So if you're going to take the tips from this presentation, you're going to go build out your own lab to do maybe some soldering, be aware of safety. Do not, I mean, there's so many things wrong with this image, right? The first is, if the soldering iron was plugged in and hot, she would be burning her hands and it would hurt really, really bad. I'm sure those of you that have done soldering have gotten a burn or two over time. So please be careful when you do this kind of stuff. We'll also talk about fumes, some, fans and specialized devices to remove the fumes. Most of the solder today does not include lead. So if you go into your grandparents' garage and you're pulling out some solder from many years ago, it probably has lead in it, which people tell me is really awesome to solder with, but not good to breathe in, like at all. You should not be breathing that in. Flux is also very bad to breathe in. As you can see, I mean, unless it's out of the frame of this picture, there's nothing there getting rid of the fumes, nor, static electricity will fry things. Also, just jamming a soldering iron on a motherboard's probably not the best idea either. So please exercise safety in these various aspects. Okay. The first thing is fundamentals on space and logistics. I find that, I mean, you could do this in a small space. And in fact, I've seen some pictures of people who have set up, their kind of workbench lab at home and really just used like a mid-sized desk to put it on. I find the more space, the better, because you're going to acquire a lot of stuff. I had some stuff and I acquired more stuff, and I had to do a lot of rearranging to accommodate that stuff on I'll show you some pictures of my setup later in the presentation, but I had to set up a pretty large work area. So take that into consideration. I mean, you're definitely going to want this stuff in one place, and you're going to want to have a good amount of space. I mean, the more space that you could get, the better. Also, when you're selecting your space or building out your space, consider the power requirements. Make sure that there's outlets near where you're working, right? You're gonna have a lot of things to plug in. You're gonna want to plug in your soldering iron, and you're gonna want an outlet that's easy to access, and one that meets standards for quality, because the soldering iron is going to get hot and do some draw, as well as your bench power supply, your hot air rework station, which we'll go through. All that stuff's going to need to be plugged in. At my desk in my other office that I'll show you pictures of, the outlets are mounted above the desk for easy access. So that's a great little tip as well. Also, you're going to have a lot of little parts and pieces, everything from soldering tips to DuPont wires to pinout headers to small screwdrivers, little tweezers, all those things. And it can be kind of daunting to keep that stuff organized. I'm not the most organized person. So I made sure, and you'll see it in my setup, those really inexpensive plastic drawers or bins, right? Those are super helpful for organizing this stuff. I also bought some carrying cases to carry a lot of my gear and cables with me. This particular company, I've got a few of their organizers, and I bought this set of 3, and like basically I've already filled them up, right? With all kinds of different cables and battery packs and Raspberry Pis and things like that. I try and keep all that stuff in these packs. So I have a set of stuff that I could take with me if I needed to. And I also have the bench set up. So, but these things will fill up fast. So plan on purchasing in your budget for both organizers that are dedicated to your space, in addition to some travel organizers as well. Okay, you'll also need some Fairly, I mean, you could say specialized tools for setting up your hardware hacking lab. I find that when you do purchase a tool that is meant to accomplish a specific task, you get better results. Like you can see those small little wire trimmers. When you do soldering, especially if you're soldering like a pin out, really actually if you're soldering anything on the board, the lead will go all the way through the board. And once you solder it, you'll have to trim that excess. And I had a regular pair of, excuse me, of wire trimmers, and I didn't feel like they were precise enough. And obviously, it turns out they make better, smaller wire trimmers just for that purpose, which I linked to there. So it's a little easier. Most of the things that I purchased, aside from like your soldering iron, how to rework, and things like that, are pretty inexpensive, right? Like this set of pliers from Amazon, you get two of them for like I think it's $7.99, which is great. So you can have one in your workbench, keep one in your bag or whatever. So that's nice. And also, one of my coworkers, Dave, recommended the iFixit Protect toolkit. Now, I had a couple of small little screwdriver sets. Like I had this one right here that I bought that I keep in this office area, and Dave was like, you got to get the iFixit kit. So the iFixit kit was a kind of expensive. I mean, it was $75. You do get more than just screwdrivers in it. But they're like, I feel like this is an indication that I'm old now. I was like, these are really nice screwdrivers. I think these are really like, they're just really nice. So if you want to splurge on something, that actual kit right there comes with the spudger, right? That's what you want to use to break open cases for the hardware. You can see it in the blog post that I linked to earlier. I didn't have a spudger handy when I was working on one of the particular devices, so what I called my super duper elite hacking tool, which is actually right here, happened to be handy. So my little Swiss Army knife, and the can opener piece actually works pretty well as a spudger. But again, you can buy spudgers and all that stuff on Amazon pretty cheap. And again, the iFixit kit comes with it. So I really like the iFixit kit. Highly recommend that. You will also need, not in the picture here, but several small tweezers. If you search on Amazon for electronics tweezers, you can buy a set for, roughly $10 or whatever. And you'll need that for, manipulating electronics and working with very small pieces, especially if you're surface mounting things like LEDs that are very, very small. You definitely want like a nice pair of really small tweezers. Don't go in your bathroom and try and use, those tweezers. You definitely want the ones that come to a very fine point. In fact, the iFixit kit has a couple depicted there as well. All the way on the left are the ones that I like to use, especially, like I said, for things like LEDs and very small surface mounting. Okay, and again, you'll see actually some of the pictures, if you go to Tractor Supply or Job Lot and you buy an inexpensive, tool, it'll probably work just fine if you're on a budget. Harbor Freight tools, that's another good one too, Harbor Freight tools. So the next thing you're probably going to want to have, at the very least, you're going to need a soldering iron. There's lots of options for both soldering irons and hot air station. So soldering iron is what you're going to use to solder things together. A hot air rework station is what you're going to use to pull things apart, to melt solder. Now, those two tools can also be used interchangeably as well. They can be used to solder things on or solder things off, but it's nice to have both. They also sell, Larry has a pretty nice one. It's a hot air rework station and soldering iron all in one, which is really nice. And you'll see, I'll describe a little project that Larry and I did a couple of weeks ago, where he helped me out with some removal of a chip off of a board. So I'll talk about that coming up as well. Also, some soldering irons have, the base station has a place to plug in more than one iron, which is really cool because as you get into this, you'll realize that the soldering tip that you're using for a particular task might not be the right size and or shape. So then you have to change the tip out. And if the iron is super hot, either have to be like super careful and use tools to take it off, or wait for it to cool down, which is annoying. Or you can get one that has more than one soldering iron attachment to it, or you can have multiple soldering irons on the bench as well and warm both of them up so that you don't have to change a tip. You can just grab a different iron. So the other thing for more advanced work, we were talking about this with the research team. Hot plates are pretty much, it looks like a scale, except it heats up a plate, so you can place electronics on top of the plate and it'll heat up the entire board, including some of the components as well. That's for slightly more advanced, hardware, either hacking or reverse engineering. Certainly not a requirement, but as you do more of this, or if your goal is to do this professionally, right, using a hot plate is something to do. Now, I have heard of people using kitchen appliances for this. Please don't do that on your own time, risk. I'm not recommending that you do that, but I have heard people using kitchen appliances like toaster ovens in place of the hot plate. But you want a hot plate. They're actually not that expensive. And the great person who messaged me on Twitter, Voidstar, A for the day. Voidstar had, it was interesting. We ran a segment on the Paul Security Weekly podcast talking about getting into hardware hacking. I linked to that in these slides as well. And Voidstar, he messaged me on Twitter, or now X, and was like, "Hey, I'm working on this guide," and he put a guide together, and his guide is amazing and awesome, and you should go check it out. And I thank him for that contribution. He's got a great section on soldering and soldering irons. It includes recommendations for hot plates and things like that as well. So that is a great resource. Okay, part two. So you want some quality soldering tips of various shapes and sizes. Now, I didn't really I should have probably consulted with my friends and my coworkers here about which soldering tips are great. I ordered like a random kit from Amazon that came with some different size tips. You want to do the research and make sure they're going to fit on your soldering iron, and so you got to research that. But you definitely want to have a variety of shapes and sizes, and you could buy a kit, from Amazon or probably a number of other outlets for that. You also want a fume extractor, at the very least a small fan to push those fumes out of the way so you're not breathing them. Or a lot of the way the fume extractors work is you have to put them pretty close to the area where you're working in order for them to extract the fumes, especially on the lower end of those fume extractors. Some of the complaints online are that I have to put it really close to where I'm working, otherwise it doesn't extract the fumes away. So there's lots of different options and price ranges for fume extractors. Again, at the very least, I think we went in our garage and we found a small fan, and we put a small fan there for now, and we'll shop around for a fume extractor as well. You're also going to want, a lot of this comes with, if you buy a hot air rework and or soldering iron, this will come with it. So you need some flux, you need some solder, you need lighting and optics we'll talk about. Extra hands, you can see there. It's not called extra hands, it's called something else, and now someone's going to be shouting it out as I say that. Helping hands, it's called helping hands. And some desoldering braid, right? So like flux, solder, desoldering braid, and soldering tips are some of the small little pieces and bits and pieces you'll need to outfit your lab to do some of the work. I'll show you how we use some of the desoldering braid as well. The helping hands is awesome. Mine came with a magnifier and a light. You can see that's actually my oldest son who does welding, and said, "Dad, I want to learn soldering." I'm like, "Sweet, let's go solder some stuff together." And he's really, really good at it because he does welding. So we enjoy putting a lot of just random projects together and solder them. You can see there, that is an Adafruit TVB Gone. That was like my son and I's first official project with, a lot of the new gear that we built. So that was a lot of fun to put together. Okay. There's a lot of spooky experiments out there too. And, I also want to caution in the terms of safety, but also interesting stories. It was 1780 where someone discovered that you could make the muscles of a dead frog twitch and jerk with sparks of electricity. Could be a fun project. for you at home to do safely, perhaps if you're into that kind of thing. Now, of course, this article is really interesting to read, especially around Halloween time. And it gets into some of the details about how other people went, oh, that's kind of cool. I want to put electricity to other animals, and some really, well, let's just say spooky things happened with that. So if you want a little diversion and read about some spooky experiments, that is the article for you. It definitely conjures up some pretty graphic images if you want to go read that. Okay. A multimeter is probably something you have laying around, right? Like the Klein Tools one that you see depicted in this picture right here was one that I had, laying in the garage that I used for, electrical work and whatever. And so that was my original one. It was also Dave, my coworker, Dave Maynor, who recommended the Handtech 2D7 II oscilloscope and multimeter. So it's a 2-in-1. I don't remember what is the cost on that. I mean, when you click the link, you'll see what it is. For the value, from what people say, of all the stuff you get, the digital multimeter along with the kind of like bare bones mini oscilloscope that comes with it, people say it's a great value, and it comes with a bunch of really cool test probes for both the multimeter and the oscilloscope portion as well, which also come in handy. This multimeter is awesome. I mean, it's like an awesome tool. I've only used it a couple of times because I just got it a couple of weeks ago. But I really, a little bit of a learning curve, but I really like it. And one of the projects that I was working on, this kind of falls in like don't try this at home kind of arena. But I did have a battery for one of my Segway like balance things. It's a 9-watt device, and the battery won't charge. So when I plug the charger in, the battery won't charge. And I saw a lot of tutorials online and on YouTube where people were actually cutting the cable from the charger and attaching the leads directly to the battery. I didn't really want, and then I saw other tutorials where they're putting something in positive and negative on the charging port, which you can see depicted there, and then using that to directly charge the battery. I think there's some bug in the battery management system which isn't allowing it to charge through the charging port. Sometimes if the battery goes below a certain percentage or gets too low, the battery management system will refuse to charge it, so you have to charge it directly. I think there's still something wrong on my battery management system, so I ended up ordering a new battery. And my good friend Larry Pesce, he does a lot of hardware hacking and always has for the 20 years I've known him, is going to help me take apart the original battery, which is not for the faint of heart. Again, very dangerous. But I think there's maybe some bad cells in there that aren't charging at all. In any case, I did use a lot of my new setup, including the test probes. So I purchased a couple of these are very inexpensive test probes. And they come with all kinds of different adapters. And I was able to customize, the needle-like connectors to go into the charging port, where I ran that directly to the battery, which had these kind of hole plugs, which fit in my test probes. If I stripped off the plastic that was around them, it exposed the kind of like springy test probe thing that I put onto the battery. And you can see there, like the light is red in the charger and it was charging, but it still didn't charge it enough for the charger to do that. Obviously, I used my multimeter to see how much voltage I was getting off it. I think I was still short. I think I could only get it to output 30 volts. I think it needs at least 40 something for the regular charger to be able to recognize it. So that was one project where I had to use these different test probes. So those are certainly very handy to have around, as well as a really nice multimeter. But again, you can use a very inexpensive multimeter, totally fine. There's really any multimeter is going to be totally fine for you. Okay, next thing to think about is magnification. Now, I am old. As I get older, I reached a certain point where I had to put use reading glasses and stuff. So magnification is super important for me. because it really helps. You know, my son doesn't have that problem, so oftentimes he doesn't have to wear the magnifiers to do the projects that we're working on. But I need the extra magnification. And I actually bought the head magnifier, which I linked to there, which you can see in the picture and see me wearing it. And it looks like I have crazy eyes, but that's just because there's magnification on there. So I think that picture is actually kind of funny. But I look like I have crazy eyes. And so I like that headgear. It has a light on it. I turned the light off when I took that picture, but it does have like a little rechargeable LED light on it, which is helpful, and comes with 4 or 5 different attachments for magnification. You can use a jeweler's loop. You can use headgear that just has a jeweler's loop on it. I really like this headgear. Again, when I was building computers primarily for the podcast studio and for myself, I needed some extra magnification, so those worked out really well. USB microscope is really nice to really zoom in on the electronics to take a picture of the chip so that you can see which type of chip that it is. So what we'll do is put the board underneath it, adjust the USB magnifier, snap a picture. There's lots of different models. I bought a really cheap one on sale. It was like $27. You probably want to get a better one than I did. I just did the bargain thing. And so you snap a picture of the chip, and then I like to put those pictures in Google Photos and tell Google Photos to transcribe the text from the image into text that I can copy and paste. Was kind of one of the little hacks I used recently. So I was just using my phone to take pictures. But when I go do this the next time, I'm going to try and use the USB microscope. A USB document camera works great for broadcasting. So I interviewed Blenster, who teaches soldering at a lot of different conferences, and Blenster had one of these types of cameras, and he was showing us how to solder live on the air, probably about a year ago now. And that was really cool. So my coworker Chris recommended this Hovercam Solo 8 document camera. It works with Linux, and it is $30 on eBay. So that link actually goes to eBay. And he was like, this is the one to get. So that's the one I got. The bonus of that lamp, and you'll see it in the picture of my lab later on, is it also has a light on it as well. So extra lighting on your headlamp and your USB camera, like all that lighting really makes a big difference and really helps out. Okay, logic analyzers. Again, if you're just starting out, probably not going to jump right to using a logic analyzer, as most of the legit ones are really expensive. The Celia Logic 16, I think they stopped making the less expensive one. I want to say the Celia Logic 16 is $600-ish, like in that range. I think the other one was you could get for like 400. And there's lots of different options for logic analyzers. I purchased one for $12.99 that's compatible with the logic analyzer software, which name escapes me. I said I wasn't going to talk about software on this one, but there's software that interfaces with the Celia logic boards that can also interface with this inexpensive $12 USB logic analyzer from Amazon. I haven't tested it yet. The use case, very simple use case for your logic analyzer, is you're trying to interface with a serial or UART port on a piece of hardware, and you can't figure out what the speeds or the parity and all that stuff are. You can basically take a sample or analyze the bus protocol, for example, from that, and then match that to a known sample to figure out, hey, what kind of serial port is this, what speed does it want, and that kind of thing. So really cool if there is a budget logic analyzer. My coworkers and friends say that this one does work. They have had success with it. I have not tested it yet, but for $12.99, I ordered one, and I'm going to mess around with it. So oscilloscopes, again, logic analyzers, oscilloscopes are kind of more in the advanced bucket. If you probably not going to need these devices if you're just wanting to hack around and put some stuff together, solder some basic things on, solder a pin header, things like that. You don't need this kind of stuff. But if you're doing more advanced hardware hacking or reverse engineering, things like an oscilloscope can be useful. Again, VoiceStart breaks down the whole oscilloscope versus multimeter. Right, your multimeter is a digital readout of your electrical signals. An oscilloscope is an analog readout, usually in waveform, so you can see a representation of what's happening in your electrical signals. When I talk to one of my friends who's an electrical engineer, he says oscilloscopes are awesome because I can actually see what's happening on the chips and between the chips. He's like, I know I wrote the code, I put the code on the chip, like I can't see it doing anything. It's just a chip sitting there until I hook up the oscilloscope. He's like, then I can see when my code runs and changes the electrical signals. So I thought that was a great little like use case from an actual electrical engineer on the kind of importance of an oscilloscope. Again, the Handtech device I linked to earlier has an oscilloscope in it. Obviously, if you want a dedicated one, it's going to be an increased cost, and there are several options available. This one happens to be $400. The other thing you'll need is some pinouts, pinout headers, and DuPont wire. So let's talk about DuPont wire first. And I have any hands on the, oh wait, I have some DuPont wire here. You can actually see this is a USB to serial device with some DuPont wire. And basically, to get started, you're going to want to have, basically the kit that I linked to here on this slide. So you've got 3 different kind of gender options, right? Female to female, male to female, and male to male, in all kinds of different colors. And again, it's not expensive to buy that stuff. And that's so you can interface between your devices, such as this USB to serial device, which I have a link to later on in the slides as well. You can interface this onto a board. This is for serial, right? So there's transmit, receive, and ground. And you need the right little connectors, right, to connect between these pinouts. So you buy the kit and you keep these handy, and then you always have them, which is nice. And then I bought 2 different kits so far for pinouts. I bought a 2.54 millimeter, which is the pretty standard spacing between the pins. One of the boards I was doing, which is not here, but one of the boards, this one doesn't necessarily, this one has it. I'm not sure what the spacing is, but some of these boards have tighter spacing. I don't know if you can see there's a transmit, receive, and ground. It's not a through hole on this one. It's a surface mount, which I haven't soldered anything to yet. But when you do the through hole, I was like, why doesn't this line up? And my coworker Chris was like, dude, you need 2 millimeter pinouts for this one, which are closer together. So I had to order one of those kits. But it's nice now, once you've got these 3 kits, you're good. Did I spell I spelled breadboards wrong. Thank you, Bob, for pointing that out. I did. I put bead boards, but you're absolutely right. Breadboards also do help for holding stuff in place. Some people use them when they're soldering the pinout headers on. Breadboards can be used, obviously, to make connections while you're kind of prototyping and doing stuff. So when you order this stuff, also order up some breadboards as well. And I will fix that in the slides. It's typo. Okay, one of the things that you will need a lot of doing this type of work, I found, are different types of USB cables. There's just, as many of us well know, there are several different types of USB cables, and you need to have most of them handy. Otherwise, you're going to be in the middle of your project and you're going to be like, oh, no, I don't have a USB 2.0 USB-A to USB-A cable. And I use that as an example because I needed that for the recent project, because this device was being a pain in the butt. This is the X88 Pro 10 Android TV. And you can see here, it's got a USB 3.0 port and a USB 2.0 port. And in order to interface with the Android debugger over USB, you have to plug into the USB port. But since it's USB A, I have to go USB A, or I mean, I could probably use some other kind of adapter or connector, right? But better off to have the actual cable that goes USB A to USB A. I didn't have one, so I had to order it, right? So it's like $3.99, and I stick it in the bag. I probably should have ordered more than one, because cables wear out, or you just might need more than one for a project. That particular one, I only have one. I also have a USB 3.0, USB A to USB A. And of course, the connectors and stuff are different between USB 2 and USB 3. So you want a smattering of everything. So you can kind of see here, you're building out your kit. This was like a Hack 5 little carry case that I had from years ago, that was given to me at DEF CON. It had a whole bunch of the Hack 5 hacking stuff in it. And so I put the other stuff somewhere else, and I made this just for cables, right? So I've got my USB 3.0 micro B cable to plug into my SD card reader. So you need one of those, right? My USB Type C, mini USB, which a lot of the, hey Bones, can I have the Bus Pirate? Hey, thanks. He's such a great assistant. So this is the mini USB. It's like you'll recognize it as like the older USB. So when you power up your Bus Pirate, for example, and some of your like alpha Wi-Fi cards, it's this USB connector, which I believe is correctly called USB 2.0 mini USB, I believe. So you'll need some of those cables hanging around, and like you may have done the silly thing and thrown them out, like, oh, I don't need these cables anymore, until you need one of those cables. So make sure you have some of those handy. And again, it was, I bought, I think, a pack of 3 for $5.99. And then I collected a bunch of other cables, right? I've got regular micro USB cables. I've got micro USB to micro USB. So you need all the weird stuff. Also, I picked up one of the devices that I had. If you were to plug into the USB port and give it power through that USB port, because that's where it got power from, and plug a USB thumb drive in, the bootloader would actually see that. And if a bootloader image of a certain file name existed, it would use that as the bootloader. So it's actually a way to help root the device. But I didn't have the right OTG breakout cable that did, USB power and a USB A female. So I have that now in the kit. So there's probably more, different types that I will continue to add. But having this stuff on hand is really super helpful. The other thing I did is I bought, that link gives you like 100 cable savers. There's these little plastic things that go on the end of the near the end of the cable, and I put them on all of my cables. Now, two things. I mean, it may or may not save the cable from breaking. I mean, I think that's really debatable, right? But it also indicates that it's one of my cables. So when my family or friends, or if I'm at a conference and borrowing a cable or whatever, I know it's my cable because I put a little marker on it. Yes, someone could remove the thing, but it just helps me organize that my kit all has black and yellow cable savers on there, and it goes in there. So, and it's a very inexpensive thing to buy. Okay, you will need a bench power supply. Consider your power requirements, like think about what you're going to be doing, and think about how much power your bench power supply should be putting out to accommodate your needs. I talked to some of my coworkers. I think it was Mickey. I'm like, Mickey, what? Like, you got a bench power supply back there? He's like, yeah, of course I do. I'm like, what's your recommendation? He's like, I don't know, whatever the cheapest one is on Amazon. I'm like, oh, I bought one on Amazon, like $50. He's like, perfect. So this was $50. It outputs power. It's great. It's got a USB port on it, so I'll use it to power my lamp and other things, and use it to apply power. I used it when I was testing my battery. Before I was testing my battery, I wanted to make sure that I had the right connectors, and that the connectors were actually working and providing a clean voltage reading. So I use my bench power supply to send like a low voltage, low amperage electrical signal to the battery, and then I put my multimeter on it, made sure everything was working. Then I connected it to the actual power supply. Also some people use a spare PC power supply for some of this as well. And as always, be careful when you're applying voltage and electrical current to devices, because if they start smoking, we all know that's called the magic smoke, and magic smoke is bad. And also, like, don't do things like this. This is very scary. Working with electricity is scary. Don't do stuff like this. I know I showed you an example when I did something similar to this, right? It was a lot lower voltage and amperage in my example than I believe this is putting out. But like, try and avoid doing stuff like this, because it's bad and it's scary, and I don't want to see you get hurt. Okay, flash readers. So one of the things that we did, so during this project, we had this Android TV device, very similar to this one. This one actually has a heat sink on the CPU, and I forget which one is the Spy Flash. Let's just say it's this one up here. This is pretty common, right? When I was actually telling one of our other researchers, Jesse, I was like, Jesse, let me catch you up. Like, here's what I did. I tried to root the Android device in software with apps, and that didn't work. I'm like, then I tried to root the device by messing with the bootloaders. And I said, I think I messed up the bootloader, and now it won't boot. And he just laughed. He's like, yep, that you're on the right path. Like, this is this is a part of hardware reverse engineering. I'm like, so I brought the board in, and my friend Larry met me in the podcast studio, and we brought a bunch of our gear in. And I was like, Larry, here's what I want to do. I want to desolder the eMMC chip off of this board, and I want to put it in a reader, and I want to use DD once it shows up as a USB block storage device, and I want to dump the entire contents off so I can do my analysis, right? And sometimes when you do this, the file system is encrypted. It was in this case as well. So that adds an additional layer of challenge. But the first part of this challenge is to do the process that I described. I didn't have all the right gear, like this test socket USB reader, and I don't think I had a desoldering hot air rework station at the time. So Larry brought his in, heated up the chip, removed the chip with a pair of tweezers. And then you can see in the picture, one of the things you have to do is clean that solder off of the contacts on the back of the chip, such that when you put it in the reader, it makes contacts with all the contact points on the reader and allows you to read it. I don't know if we didn't clean it up enough, or it's just the thickness of the chip was off. But what Larry did was he cut a piece of a paper plate. Like, I never thought we'd be using paper plates in our hacking journey, but we did. And so we put a little piece of a paper plate, which helps push it down a little more, and we were able to read the contents of the chip. So that's a really nice test socket reader. It's a little, I don't remember. Can I copy this? I don't remember. I didn't put the costs on here. I mean, you can shop around. So this is $136, right? So this, for me, this item was a borrow from a friend. Like, some of this stuff you're just going to want to buy. Like, if you need USB to serial adapters and your DuPont cables, that stuff is cheap, readily available. This device has been more specialized, so I'm like, for now, I'll just borrow this device. So you can borrow if you have a friend, locally, absolutely. Borrowing some of this stuff is totally fine. All right, USB to serial and other protocols. So I picked up, now this one that I keep holding up right here is the High Let Go. It's a CP2102 chipset that allows you to do USB to serial communications. It's like really inexpensive. Let's do this one now too. This device is $7.39, which is great. And it works just fine. So you can buy that at Amazon, $7.39. The Adafruit one is kind of marketed as plug into your Raspberry Pi. So you can see here, I've got Raspberry Pi, and I should have probably had a slide of where you plug in. I mean, you Google it, but like basically these back pins, two from the left right here, are receive, transmit, and ground. I even think it's in that order. And you can get a serial console on your Raspberry Pi. So the Adafruit one, which I don't physically have, you can see a picture there. That one's really good. That one works really reliably. And then you also have your Bus Pirate, right? And your Bus Pirate's going to do more protocols. It does JTAG, SPI, and a couple of other protocols. And this is a really good tool to have. So I use the Bus Pirate. One thing I really like about the Bus Pirate is, hey, Bones, can I have that pin header? Thanks, man. You're awesome. You're awesome. Good job today. So one thing I like is the breakout cable that comes with the Bus Pirate, right? Has the piece that plugs into the header, and also has these little cables that come out. And these are just regular DuPont cables, but they've got just a little plastic coating, right? So they don't have the big plastic block that's on there like that. They that's been stripped away, and you can use it without but if they put some kind of little rubber coating, some heat shrink over it. And I really like that, especially when I was doing the 2 mm pinout header. I used this because the pins were so close that these were like too tight. It wouldn't fit. And you definitely want some kind of coating because you don't want things touching, otherwise things aren't going to work if you're basically shorting the connection. So I really like that. I'm kind of in search of DuPont cables that come like this, and I can't find them. So I'm thinking of just heat shrinking, stripping off the bigger plastic things and just heat shrinking to have some in my kit because it was super handy. So that is Siri protocols. Wow, time is flying. Okay, Raspberry Pis. Bones, what'd you do with my Pico? You dropped it. Oh, you were doing so good. His arm's getting tired. So have a bunch of Raspberry Pis handy. This is a Pico W, so it has the wireless on it. So that's handy for a lot of reasons. So things I use for my Raspberry Pi is I did an Ethernet bridge, a transparent Ethernet bridge. So someone's asked a question, why do you need a flash reader to dump JTAG? These devices did not have a JTAG header. You could use JTAG to dump the flash, but these Android TV devices I was working with did not have JTAG. A lot of commercial stuff and other devices do have JTAG, which you could use to dump the flash. So if that's not there, you have to remove the flash chip from the board and then use your flash reader. So that Ethernet bridge. So I set up a Raspberry Pi. In fact, this is like my next prototype of my Raspberry Pi. So Hack5 does sell the Packet Squirrel, but I just wanted to try and build my own. So this one I got an Ethernet hat, and I put it on. This is a Raspberry Pi 3, and basically I want to create an Ethernet bridge so that I can plug like this device over Ethernet into one port, plug the network into the other port. And then ideally I have rules on here that prevents that device from talking to other devices on my network and allows me to capture all of the traffic coming through it. Also, I did a Raspberry Pi, you can see depicted there, for the Apple Bluetooth Low Energy Spam. That was a fun little project as well. I did one of these Pico Ws. I did the rubber ducky script on here, so it acts like a Hack5 rubber ducky bad USB device. And one of my Pi Zero, somewhere around here, but have my Pi Zero, you can see a picture of it. I just loaded Kali Linux on it just to have one loaded with Kali Linux. So dedicated screen, battery packs. Battery packs are cool. You should have a battery pack for your Raspberry Pi. I didn't put a link to the one I bought in there, but really most of the higher output battery packs will work to power the Raspberry Pi. In fact, that top picture you can see plugged in is a battery pack that's marketed as for Raspberry Pis. Okay. And I found some resources online. I'm working to make this a little more streamlined and make it better, but I definitely stole some things from the Raspberry Pi Stack Exchange. That was a tutorial on, first link there down at the bottom is how to switch over to systemd networking and disable the other networking stack. And then these commands allow you to create the bridge, which will automatically put new Ethernet adapters onto the bridge. This seems to be working fairly well for now. I got to go through the config and just script it and test it a little more. But this did work to create a bridge where I was able to capture traffic. Or you can go buy a Hack5 packet squirrel, but that seems to be geared more towards red teamers, not for doing just straight research. Of course, there's a million ways that you could set up things to that you could set up something to capture this network traffic and kind of quarantine it in your network. There's a lot of ways to skin that cat. Okay, RF hacking really quick. This is my RF hacking cheat sheet. You're going to want a hack RF1, a Proxmark 3, an RTL SDR, a Wi-Fi dongle that works great with Kismet, and this is the one that is recommended from the Kismet project. And for Bluetooth dongles, I really like the Zexmite Bluetooth adapters. One has a removable antenna, one does not. They're all fairly inexpensive. Also, if you order your hack RF1 from AliExpress, like I did, I don't recommend that. Go buy it from Garrett at Hacker Warehouse. But if you do buy it from AliExpress, it is significantly cheaper. And I forgot to preload the SD card with all the config files on it, and I got really bad error messages, and I thought I got a dud, but it turns out I just needed to load the SD card and put the SD card in with all the right files for the PortaPack, and that worked. So that's your RF hacking hardware cheat sheet. Also, there's some UDA 100s up there as well that I've collected over the years. The word that I get is that those are running kind of expensive right now. So the devices that are listed here on the left-hand side are the Zexmite stuff is pretty good, and ones that at least Larry is looking at more seriously for some of the Wi-Fi hacking courseware that he's working on. Okay, your Flipper Zero, good to keep with you. Better to have the tools on this slide than to have this. This is great because it's kind of like a Swiss Army knife. You can keep it with you all the time. And yes, the Swiss Army knife has scissors on it. Are they the best scissors in the world? No. Can you use it to cut stuff? Yes, but they are still pretty crappy scissors. The Flipper Zero is very similar in that it does have a lot of the Wi-Fi and wireless and RF components on it, but in one neat little package. One of the things that I like too is that, I mean, if you happen to carry like DuPont cables with you, that's one thing. You can use it as a USB to UART bridge. You just plug into the top of it. I don't have mine. I don't have the one in the picture handy. I do have this one, but this one I pretty much, holding up for the camera, I leave in the case as it has the Wi-Fi dev board, which is loaded with Marauder on it. And this one I run the Unleashed firmware. On the other one in the picture, which is not running Rogue Master yet, I can tell by the screen on it. I run the Rogue Master firmware. It's simply because it's really bleeding edge, and you get a lot of apps like for sending Bluetooth low energy spam already pre-compiled, and they're just doing it right on the release of that firmware. So it's not going to hack all the things, as you might see online, like, oh, I used a Flipper Zero for this. There's much better tools, obviously, but it is nice to keep with you. I do keep a lot of the latest copies of the RF and infrared databases that I found. There's some good GitHub repos out there that I use rsync to rsync it to my SD card, so that I've constantly got an updated database of all the IR signals and sub-gigahertz files for it. And you can buy lots and lots of toys and add-ons for the Flipper Zero, GPIO add-ons, including that antenna is actually a sub-gigahertz antenna, which is kind of cool. So Flipper Zero, again, good to have as kind of your Swiss Army knife, but doesn't replace all the other tools that I've mentioned. Okay, this is a picture of my very messy lab. It's really hard to keep this stuff organized, but you can see. Um, did I talk about tweezers and stuff? I had a link to. I must have skipped over it. There is links in here to the what do you call them now? Now I can't remember what they're called. They're locking. Good Lord. I had it in the slide and I glossed over it. Uh, hemostats, hemostats are used for like surgery and stuff, right? But also good to have some of those. Those are depicted in the left. You can buy a kit on Amazon very inexpensively. They're also called locking forceps. You can search for as well, and so that's good. Digital caliper or regular caliper is handy too. I realized once like I put this kit together, like, wow, I've got all the tools. Like I could fix, my son's broken pocket knife, and figuring out what parts you need, for the pocket knife. I was using the caliper, for that. So, and you can see all basically the gear I talked about here. I got that screwdriver set that's in the back upper right-hand corner for like $20 at, Tractor Supply. And it came with a whole bunch of stuff. So if I needed a bit or a different screwdriver or whatever, I didn't have to go to the garage and get it for $20. I can have a pretty cheap set there. And you can see all the stuff that I talked about, my little plastic drawer organizers as well. And on the other side, you can see I do have another soldering iron, the USB microscope. That's actually the pan tilt zoom attachment for your phone. One of those things. What is that called? A jib. That's a handheld jib for your phone. If you need to take a video of something, you could use something like that. I did do a soldering mat as well to protect the desk, and it came with little organizers, which are handy. Um, yeah, and that's so some resources for this. Again, a huge shout out to Voidstar, who was working on this guide, kind of as we were also working on some of this content as well. One of the things that drove the content for this is a blog post that we made called "My Favorite Things: Hardware Hacking and Reverse Engineering." There are more software recommendations on that post if you want to check them out as well. So the first link is a blog post, Voidstar, and then episode 802. Myself, Larry, Josh, and others talked about getting started with reverse engineering hardware. And there's lots of links and references, as well as like a whole hour-long discussion, where we talk about classes you can take or free courseware, all the way to how to learn soldering. So thank you, everyone, for attending today. Hopefully you learned something and got a couple of tips and tricks for your hardware hacking lab. Again, if you're interested more in Eclipsium, a lot of this presentation today was driven by our research team, that does a lot of this stuff on a day-to-day basis, that ultimately fuels our product, right? A lot of the work that we do in research fuels our amazing product. So you can get a link to the demo, book a live demo at eclipsium.com/demo. We also have the Below the Surface newsletter. We do a regular podcast and a newsletter under the moniker of Below the Surface. So you can check out the podcast episodes and subscribe to our newsletter on the links on those slides. And Matt from Voidstar, thank you so much. You're amazing. Thanks for everything you do. And you definitely helped inspire this. So this is all good for ethical hacking. I mean, ethical hacking is just a matter of your values and morals. So yeah, I would say this is for pen testing and or ethical hacking. Uses a lot of these. I know when I ask some of my pen tester friends, right? I'm like, hey, when you are doing like a physical assessment and you want to do a rubber ducky attack, I'm like, what are you doing? And I think Larry was telling me that most of the testers get like one of these little Raspberry Pi Pico devices, and they're customizing it much like I did. And you can even, one thing I didn't talk about was 3D printing. I did not have 3D printer recommendations. You can ping me about those. Larry has told me, and Jesse and Chris have kind of given their recommendations, so I can put together something if you're looking to do some 3D printing. And the reason I mention that is like once you get like this little tiny board where you want it, you probably just want to 3D print your own case, right? I mean, you can buy the cases, but 3D printing your own case for this and for a lot of the things that you do is it comes in handy. So having a 3D printer for that stuff is great, especially like if you're taking this on your pen test, you want to protect it. And you want something inexpensive too. You want to, print your own. It's really cheap once you get your printer set up. And then if you lose it or drop it or it breaks, it's not a big deal. So we are at the top of the hour. Any remaining questions? Thank you for the wonderful feedback. Melissa, back to you.
Great. Okay, so of course the number one question was, are the slides going to be available? And the answer
Yes.
is yes.
Yes, we will
They
send
are
you.
going to be
I know there's
available.
a lot of links to a lot of cool stuff to buy on there. So yeah,
I think somebody referred to this as their Christmas list.
it's very much that.
Everybody be on the lookout. I'll be sending out the links tomorrow, both to the recording as well as a link to the PDF of the slides so that you can get a head start on your Christmas shopping. Also wanted to let you know that another member of our team, Scott Shefferman, will be speaking on the SANS Cyberfest ransomware track, which is taking place this Thursday. I'll include a link in case that is of interest to you as well. He'll be showcasing some of the latest threat landscape research that has taken place with ransomware, kind of the situation that never goes away. And we hope to see you on the next webinar. Thanks again, Paul, for hosting.
Thanks, Melissa. Bye, everyone.
Bye, everyone.
Thank you.